So, good afternoon, class. Welcome to the next session of our assembly computer organization class, no, COA. Today we'll be discussing and continuing the discussion on magnetic disk, yung ating RAID, and hopefully matapos tayo dun sa ibang chapter. Ayan, para ready tayo sa Friday. Okay. So, 34. Okay, so 34. 5, 7. 5 na lang. 5 na lang, ano? Tama.
5 na lang.
Okay. So, mayroon lang akong ipapanood na video regarding dun sa ating next na topic, which is I/O. Ayan. I/O. Tapos tutuloy ko yung ating discussion.
We used to communicate. I called out.
Okay.
Everybody has seen a computer. In fact, we use computers every day. But how do they work? Every computer follows a simple series of events that helps make them useful. This starts with an input. An input is any information that goes into a computer. This might be the press of a key, a click of a button, video from a camera, or even the temperature of a thermometer. Devices that provide information to a computer are called input devices. Once the computer has received this input, it spends a tiny fraction of a second calculating what this information means and how it will need to respond. This is called processing and is done in the computer system's central processing unit, or CPU. As soon as it finishes working this out, the computer often lets us know by producing an output. An output is a way for the computer to communicate with the outside world. This can include sounds, pictures on a screen, or even movement of a robotic part. Devices that a computer system uses to communicate are called output devices. You might be thinking, okay, that seems pretty reasonable, but how does a computer know what to do? This is where programming comes into play. All computers use a special set of instructions called programs to help them decide what to do. These can be very simple, like in a calculator, or very complex, like in a supercomputer, and without them, your computer is little more than a brick. The final part of the puzzle is storage. Storage is used to keep information for later use. Sometimes data must be saved to storage, and at other times it needs to be retrieved from storage. Devices that hold information are called storage devices. In essence, this is how a computer works. But let's look at some examples. Let's say you're video calling a friend. The input to your laptop is the video and audio going through the webcam. The computer then processes the video and audio, breaking it into parts to send to your friend. When it reaches your friend's computer, it's output onto their screen as video and through their speakers as audio. But wait, where did all these special effects come from? When making the call, you decided to play with the video calling program and add some filters to your video. This means a bit more work for the processor, but it's a lot more fun. The images for the filters are kept on your computer's storage, and are opened as you add them to the stream. As another example, let's look at a calculator. Let's say you press the 2 button on your calculator. This is the input. The calculator spends a fraction of a second processing what it needs to do, then displays the number 2 on its screen as an output. If this seems a little complicated, you can think of it like this. Input is how a computer gets information from the world, allowing us to communicate with the computer. Processing is the computer calculating what it should do next. Output is the way the computer can communicate with the outside world, including us. Programming is the instructions given to a computer, so it knows how to process information. And storage is how a computer keeps information for later use. See if you can think of some examples of input, processing, and output.
Okay, so that will be our next topic. But first, let's finish RAID. Okay. So, yung ating diniscuss last time. Stop sharing. Okay, let's do a sharing on a window. Ayan. Okay. Share. So, last time, pinag-usapan natin yung magnetic disk. Pagkatapos, yung RAID, which nag-start sa 0, followed by 1 level, and then nag-end tayo sa level 2 na RAID. Ayan. So now we'll be discussing RAID level 3, no? So, dito sa level 3, no, it requires only a single redundant disk, no matter how large the disk array. So, isa lang daw yung redundancy niya, no? It employs parallel access with data distributed small strip, no? So, tingnan natin yung pagkakaiba nung lima na RAID, no? Para sabay-sabay na nating i-discuss. Level RAID. Teka. Ay, naku. Okay. Google. Image. RAID 0 1 Nasaan na yan? Ito, ayan. Para isang discussion na lang. Pwedeng lakihan to. Malaki na. Nakikita nyo na. Saan na? Ano nangyari? Ayun. Pwede na. Ayan. Isang tira na lang. Okay. So, ito yung ating RAID types, no? In terms of ilan ang disk. Alis ka dyan. Okay. Ano nangyari? Yun. Nag-o-auto. Ayan. Okay. So, dun sa natin, ang titingnan pagka sa types ng RAID, no? Meron pang hanggang 6 hanggang 50. Pero yung nandito sa atin hanggang 5, no? So, dito sa 0, merong 2 disk for redundancy. Ang efficiency niya 100%, ang cost niya mababa. Ang read performance good for both random and sequential read. Ang write performance niya excellent. Ang write penalty 1. Ang protection niya no protection, no? So hanggang 2 lang yung disk eh. Tapos yung 2 disk din. Ang storage efficiency niya nasa 50%. Okay. Pwede ko sigurong i-copy na lang yung picture. Pwede ba? Save as web page. Cancel. Pwede ba tong i-save as image? Hindi eh. Ano nangyari? Bakit hindi ko may yung sa taas? Nakakainis naman. Ayan. Again, dun sa RAID 1, no? 2 yung minimum na disk. 50% yung storage efficiency. Ang cost niya high, no? Kasi gumamit na siya ng ng dalawang sabay na disk, tapos yung ano niya medyo mabagal, no? Ang mirroring niya, meron siyang mirror protection, no? Better than a single disk kaysa doon nga naman sa ano. Okay. And then good on slower than a single disk because every write must be committed to all disk. So pareho siyang nagsisave sa dalawang disk, no? Ito, ang saving niya, although dalawa yung disk, naka-sequential, one after the other. Tapos dito, meron siyang write penalty na dalawa, no? And then merong mirror protection. So dalawang beses na siyang nagsisave, no? Tas naka-mirror pa siya, no? May mirror pa, no? So pantatlong saving 'yon ng RAID. And then dun sa 5, number 5, no? Tatlo yung disk, 67 to 97% yung storage efficiency, yung moderate low yung cost, good for random and sequential read. So pwede siyang random, pwedeng sequential. Pair to random ang sequential writes niya. 4 yung penalty. Ang parity protection niya, meron siyang parity protection for single disk failure. So parallel. Yung isang disk ang pinoprotektahan niya, no? Naka-parity, naka-parallel, no? So meron pang 6, no? 3. Pareho lang siya nung sa minimum disk niya 3 sa 5, no? Although mababa yung storage efficiency, 33 to 94%, and then extremely high low dun sa cost. Good for random and sequential read. Poor to pair yung random writes niya, pair yung sa sequential writes. 6 yung sa write penalty. Yung parity protection niya para sa dalawang disk, dito single. Parity is parallel, ha, sabay, no? Ito, isa lang yung sabay niya, single disk lang yung sa sa single disk failure. Okay, so hanggang sa pataas siya ng pataas, no? RAID 10, RAID 50, RAID 60. Okay, so sa RAID 10, 4, and then 50 yung storage efficiency. Ayan. Tapos high yung cost kasi ang dami na nang ginagamit niya, 4. Pero maganda yung kanyang performance. Good yung performance. Read performance good. Write performance good. Dalawa yung penalty. Yung mirror protection niya meron, complete. Tapos dun sa 50, 6 yung ginagamit na disk. 67 to 94% yung storage efficiency. Yung cost is moderate to high. Better, no? Ang read performance, moderate yung random and sequential write. And then 4 yung penalty, write penalty. Nag-o-offer siya ng parity protection for single disk failure. So, dun sa 60 naman, kaya halos pareho lang sila ng 6 na 6 din do sa 50, although mababa yung yung storage efficiency, tapos 33.88% yung sa storage efficiency. Extremely high to moderate yung cost, and then better yung read, pair yung random and sequential writes, 6 yung penalty, and then parity protection to disk. Ayan. So, yan yung ating RAID. So, how does it work? Okay, ganito yung niya. Ayan yung naka-RAID, no? RAID 5, ito yung RAID 5, no? RAID 1. So, okay, balik tayo dun sa ating ayan. So, ayan, no? Inisa-isa na natin yung RAID, no? Base dun sa niya, sa performance, no? Nakita nyo dun sa ating ating dun sa image. Ayan. So, dito, ito naman yung RAID comparison 0, 1, 2, 3 na level, no? Advantages and disadvantages, no? So, yung mga applications nung 0, maganda siya sa video production. Yung 1, kung financial, no? Maganda siya sa accounting. Yung 2, non-commercial, no? Non-commercial implementation. Nandito rin yung disadvantages niya, no? Yun nga, doon sa sinabi natin doon sa image kanina, no? You have ang advantages niya, 0 ang performance, greatly improved, no? No parity calculation, very simple design. Ang disadvantage, the failure of just one drive will result in the data array be lost. And then, doon naman sa 100% yung redundancy ng data means. And then, doon sa disadvantage, highest disk overhead. No? Mataas ang overhead ng disk. Yung palitan, pagpapalit ng disk, no? 100% siya na inefficient, hindi ganoon siya ka-efficient. So, yung 1, magandang application niya pagka nagka-calculate, no? Mataas yung calculation. Kaya katulad ng mga accounting, payroll, yan. And then 2, extremely high data transfer rate. Okay? Yun ang advantage na. Very high yung ratio ng ECC disk, no? So, inefficient din siya. Nagre-require siya ng high transfer rate, no? Sabi dito, dun sa application, no commercial implementation exists, not commercially viable. Ayan. Tapos, ito naman yung susunod, yung 3, 4, 5, 6. Okay. Doon sa 3, very high yung read ng data transfer. Transaction ay ang disadvantage na equal to a single disk drive, no? Tapos, maganda siyang i-apply sa video production uli, no? Mga anything that has something to do with video, no? Number 4, very high rate ng data transaction. Pwede siya sa complex, kaya lang nag-aggregate siya, yung transfer rate niya inefficient, no? So, nagre-result sa disk failure. Yun naman yung disadvantages niya. Again, no commercial application. 5, highest rate yung read transaction rate. Most complex siya. So, medyo mahirap i-build. And then, maganda siyang i-apply sa file and application server. No? Kung kayo ay nagamit ng SharePoint, ayan, maganda siya sa mga file server. Ayan. So, yun yung magandang application nito, no? Tsaka doon sa mga yung Azure, no? Naka-RAID yung Azure dun sa cloud, no? And then 6, provides an extremely high data fault tolerance, can sustain multiple simultaneous drive failures. So, kung magsabay-sabay man yung drive, since marami kang naka-RAID, no, hindi ka babagsak, no. Ang problema lang dito, yung overhead ng compute ng parity address, no, extremely high. Perfect solution for mission critical application. Ayan. So, yung medyo heavy na mga enterprise application, katulad nung mga laging online na mga retail application, yung gumagamit ng siguro yung database, pwede na yung yung katulad ng Shopee na mga application nila, yung nagma-manage ng system nila. Ayan, kasi lagi siyang dapat online, no? Para makarespond dun sa requirement ng yung mga retail application na laging ginagamit. Pati rin dun sa mga banking application, dun sa mga ATM, no? Dun sa ATM, usually, naka-RAID yan. Dahil naka 24/7. 24/7 ang bukas niyan, no? Yun. maganda siyang gamitan ng RAID, mission critical. Okay. So SSD compared to HDD, no? SSD following advantages of over HDD, no? High performance input operation for second IOPS, durability, longer lifespan, lower power consumption, quieter and cooling running capabilities, lower access time and latency rates. Ayan. So wala namang nagamit ng SSD. May gumagamit pa ba ng SSD? Puro naman tayo HDD na, diba? Ano ba yung mga hard drive natin? Usually, ano na yan, HDD. Luma na siya. Yes.
Baligtad po ata. Mas mabilis po SSD kaysa sa HDD.
Mas mabilis? Solid state drive, SSD. Mas mabilis yung SSD. Okay. Sige. Okay. Sige. Tingnan natin yung bilis ng dalawa, no? Comparison. Sige. Para meron tayong comparison. Difference ng SSD and HDD. Ayan. Okay. Para meron tayong actual na ano. Ayan. So, tingnan natin dito sa ating reliability test. Ayan. This is from Securis. Nasaan na yun? Okay, ayan. Okay, lakihan natin ang ating image. Ayan. Okay. So, ito po yung ating SSD versus HDD. Usually, 10,000 to or 15,000 RPM SAS drive. So, yung sa access time ng SSD exhibits virtually no access time. So, 0.1 millisecond. Tapos, the HDD, 5.5. 8 millisecond. Oh, mas mabilis nga. Mas mabilis ang SSD. Ayan. SSD deliver I/O na 6,000. Yung HDD 400. Okay, agree na ako kay ano. Si Ken ba yon? Ken? Ikaw ba yon?
Hindi po.
Sino yon?
Ay, ako po, ma'am.
Teka. Kaya may nagsasalita. Juan Paulo. Ayun, si Juan Paulo. Okay, salamat Juan Paulo. Ayan. So, eto yung ating so mas mabilis yung yung SSD. Kala ko kasi luma siya. Ayan. Close mo nga yan. Okay, so ang dinideliver niya dun sa access time 0.1 millisecond compared kay HDD na 5.1 to 8.0 millisecond. Tapos tong sa I/O, yung SSD nasa 6,000. Ang bilis nito, no? Random I/O performance compared to 400 na I/O, no? Tapos dito sa reliability, 0.5% ang failure, no, ng SSD compare sa HDD na 2.2 to 5%. Ang laki ng diferensya, ang liit nung niya ng hardware failure. Tapos energy saving, okay, mas nakakatipid ka sa kuryente dito, no? So 2.2 and 5 watts yung niya, yung init, no, nakain sa kuryente, energy saving. This means that the larger server approximately 100 watt are saved, no? HDD consume between 6 to 15 watt. Ganun pala kalaki ang kain nun, no? And then 1% yung I/O niya, weight. 1%. Ito 7% dun sa CPU power. you will have extra 6% of CPU power for the operation. Dito sa average service time, ang I/O request niya nasa while running backup remain below 20 millisecond. Ito 400. Ang bilis nito. Mas magandang mag-save sa SDD pagdating sa database. Kasi ang response time niya nasa 20 millisecond. Hindi masyadong matagal mag-save ng backup. Input output request time, ayan, nasa 20. Ito 400 to 500 millisecond. As yung backup rate 6 hours. Ito backup niya 20-24 hours. Sakto to, tipid to sa tipid to sa pagsisave ng data. Instead na magdamag kang mag-iintay, pwedeng half a day na lang. Kasi nung nagsisave ako, pag nagsisave ako ng data sa server, iniintay kong matapos yun eh. Usually pagka ini-schedule ko siya ng weekend bago umuwi ng Biyernes, matatapos ako alas 12. Ganun katagal mag-backup. Pero kung kasi tagal na rin naman nun. Siguro puro HD pa yung hard drive namin, kaya ang tagal. Hindi pa ako nakagamit nung SSD. Okay, so yan yung ating SSD. Ayan. Ayan yung ating comparison. Ayan. Okay. So, ito sa flash drive tsaka sa Seagate. Yun yung ating solid state drives at saka mga disk drives. Mga external disk drive. Ayan. And then, solid state drive architecture. Ito yung architecture ng SSD. Okay? From host. Okay? To the interface, to controller, addressing, buffer, cache, and then flash memory components. Naka-flash pala, kaya mabilis. Ayan. Okay. There are two practical issues peculiar to SSDs that are not faced in HDD, no? So, ito yung mga practical issue niya, no? SDD performance have tendency to slow down as the device is used. The entire block must be read from the flash memory. Oh, placed in the RAM buffer before the block can be written back to the flash memory. The entire block flash memory must be erased. Ganun pala yung process na. And then, flash memory becomes unusable. Oh. So, the techniques of prolonging life, front-end flash cache delay group. So, i-delay mo yung cache. Tapos, using wear leveling algorithms to distribute right across cell block, bad block management techniques. Yun daw yung gagawin. Okay. Most flash devices estimate their own remaining lifetime so system can participate failure to take preemptive action. So, yun yung niya. Issues niya doon. Okay. And then, you have the optical disc products. Ayan. So, ito yung CD, CD-ROM, CDR, CDRW, DVD, DVD-R, DVD-RW, and then you have Blu-ray. Yung Blu-ray, yan yung pinakamataas yung pwedeng ma-save dyan sa sa DVD. Pwedeng umabot hanggang 25 gigabytes. Ayan. Okay, compact disc. Ginagamit pa rin naman to ngayon, lalo na yung mga gagawa ng research, naka-attach yung unless, doon ba sa inyo ba, bukod doon sa, kasi maganda kasi na nakaano pa rin sa CD-ROM yung yung mga files doon sa likod ng ng thesis. Yun ang alam kong ginagawa eh. Unless USB na yung i-attach. Parang mas maganda pa rin yung sa presentation. Parang bulky masyado pagka USB eh. Tingin nyo? Ano sa tingin nyo? Or, kayo, ano may sasuggest nyo? Ano mas maganda? Naka-disc pa rin yung sa thesis or gusto nyo USB, parang mas maganda yung USB. Kaso, paano mo siya ididikit doon sa ano? Kailangan may sariling lalagyan. No. Ako advisable ko pa rin yung compact disc sa mga thesis. Sa research. Ayan. Okay. So, ito yung ating CD operation. Anong laman niya? Acrylic. Tapos, made of acrylic polycarbonate plastic. Ayan. Para lang alam natin kung ano yung component niya, no? So, pag nagsisave, naka-transmit, naka-laser yung receive. Ayan. Kaya, laser disc. Tapos, ito yung CD-ROM black format, no? Naka 12 by sync, 4 byte ID, and then yung sector mode niya, naka 4 bytes. Yung data niya, 2 hanggang 2 gig. Naka-layered na 288 bytes LEC. No? So, yung capacity nitong CD-ROM, pinakamataas na yung 2.3 2 gig. No? Ayan. Okay. CD-ROM. Itong CD-ROM, ayan. Yan yung ating recordable, no? Meron tayong CDR, CD-ROM, CD rewritable. Okay. Ang component niya, polycarbonate, naka-optical memory characteristic yung niya. Ayan. Hindi ko na masyadong papadaanan yan kasi ganun lang kasimple yung niya, component niya. Okay. Plastic polycarbonate. And then, you have the magnetic tape. Ayan. Yung mga magnetic tape, reading and recording techniques niya, naka-disc, no? Flexible yung coat niyan, no? Magnetizable material. So, parang yung mga cassette tape. Ganyan na itsura niya, no? So, meron siyang umiikot na track, no? May bidirectional siya. Okay, and then ito yung mga tape drive, no? So, yung tape drive, LTO tape drives. Ginagamit pa rin yan ngayon. Okay, dito tayo para makakita kayo ng tape drive. Dun sa mga server ng LTO tape drive. Server ng AS400 LTO tape drive. Para makita nyo. Yan, o. Ito yung bukas. Ultrium SAS. Ayan. So, para kita natin. Ayun yung, tape drive. Okay. Umiikot siya. Okay. Ultrium.
Excuse me po. Yung PowerPoint lang po yung nakikita.
Ay, sorry naman. Okay, stop sharing. Hindi ko inanon as entire screen. Okay. Kasi pag naglilipat ako na entire screen. Okay, share. Ayan. Okay, ito yung IBM na tape drive. Ito yung laman niya. Ayan. So, ayun yung tape drive. Ito yung itsura niya. Ayan. Ayun yung bilog, no? Pwede siyang mag-contain ng per cartridge 6.25 terabyte, no? Merong ganito na nasa loob. Meron namang naka-flat yung katulad nung kay tingnan natin yung iba. Close natin pa. Ito pa isa. Pwede rin yan. LTO tape drive. pag magma-manage kayo ng mga server, lalo na yung ito yung sinasabi kong tape drive na bilog, no? Yan. Okay, that's another form of tape drive. Ito. Yan. Kung magmamanage kayo ng mga data center, lalo na yung mga lumang data center.
Ako may silver 3 ako.
Sino yun?
Pare ko nga.
Sino yun? Anong? Pero gagamit ka rin ng tape drive.
Question, sabi ko. Ano yun?
Gumagamit ka ng tape drive?
May luma po kami dati na parang turntable, tapos napapagana po siya.
Oo. Meron ngang mga turntable na gumagamit ng tape drives.
Opo. No, hindi po. Ba't turntable sabi ko?
Hindi. I mean, parang siyang turntable. Parang siyang turntable na pinapatugtog ganito. Yan, tape drives. Oo. Tama, meron nga yan.
Opo. Nakalimutan ko lang yung brand, parang silver na ewan.
Pero, mas...
Wala siya ko lang.
Actually, isa yan sa maganda yung tunog. Pagkatapos nito, lumabas na yung cassette tape pagdating doon sa mga sounds. Pero ginagamit din siya as a way para ma-save yung data, no? So you have this in big tape drives like this dun sa mga server farm na yun nga yung sinasabi, yung pinag-uusapan natin dati na yung scene na si Captain America nasa bunker, naalala niyo yun? Tapos merong mga bilog-bilog doon na yan. Yun yung usually na meron pa rin kasing gano'n na nagme-maintain ng mga data center na puro bilog-bilog yung ginagamit. Kasi ang mahal ng pagkakabili nila, lalo na yun sa IBM. So, ginagamit pa rin hanggang ngayon. Kaya, tsaka, ang sabi doon sa ganon, mas reliable daw yung tape drive at tsaka mas malinis yung kopya. That's according to them. Alam mo naman yung mga may loyalty sa mga dinosaur na technology. Wala kang magagawa. Hanggang ngayon nga ginagamit pa yung Fortran eh. Well, that's their choice. Ayun. So, balik tayo. Okay, so those are tape drives. There are several types of tape drives na LTO. Ayan. So, LTO 1, 2, 3, 4, 5, 6, 7. So, yan ay depende sa tracks at saka sa compressed capacity, no? So, syempre, the higher, ayan, yung compressed capacity niya mas mataas. Ayan. So, pati yung linear density, no? Ayan. Okay. So, yun po yung ating chapter 6 na external memory. So, dun sa ating mga diniscuss, pinag-usapan natin yung magnetic disk, solid state drives, magnetic tape, yung RAID, yung optical memory. Ayan. So, okay. That goes for external memory. Okay. Moving on. Let's go to chapter 7. Medyo marami to, no? Sensya na, bilisan ko na lang kasi kailangan natin matapos to para ready tayo sa sa Biyernes. Ayan, chapter 7, this is the I/O, no? Yung ipinakita ko sa inyo kanina na input-output. Yung ating addressing ng input-output module, no? Okay, so ito yung ating pag-uusapan dito, no? Okay, tingnan natin yung ating summary. Okay. So, we'll be discussing in this chapter 7, external devices, I/O modules, program I/O, direct memory access, interrupt-driven I/O, direct cache access, and I/O channels and processor. Ayan. So, yan yung ating pag-uusapan dyan, no? Okay. So this is the model of an I/O module. Meron ka dyang address line, data lines, and control lines. So, ito yung pinaka-system bus mo. And then, it links to peripheral devices, no? So, ito yung nilalabasan at pinapasukan ng ating information, no? Yung ating data, no? Input-output module natin. Ayan, yun yung ating generic module. Okay, so let's start with external devices, no? So we have here 3 categories of external devices. Merong human readable, machine readable, and communication. Okay. So ano yung mga external devices? Well, it provides an exchange of data between external environment and the computer. It is attached to the computer and linked via I/O module, no? It is a peripheral device, no? Ayan. Okay, so yung category natin, you have human readable, suitable for communicating computer user. So, mo nakikita dun sa iyong video display. And then machine readable, suitable for communicating equipment, no? Magnetic disk tape system, sensor, and actuator, no? And then communication, suitable for communicating with remote devices such as terminal and machine readable device or another computer. So ito yung category natin ng external devices, no? Okay, human readable, no? Meron siyang video display, machine readable, pwedeng mag-communicate sa equipment. And then communication, suitable for communicating remote devices do sa terminal. Ayan. Okay. So this is the block diagram of an external device, no? Naandyan yung inyong control logic sa gitna and then buffer transducer. So yung I/O pumapasok sa control signal and lalabas sa status signal, no? From the control logic. The data bits come to and fro in the I/O module, papasok siya sa buffer, tas lalabas sa transducer as data, pasok doon sa ating environment. Ayan. So, ito yung block diagram ng external device. Okay. So, yung ating another sample of external device, we have a keyboard. Okay, dun sa keyboard, ito yung kanyang description, no? Meron siyang International Reference Alphabet, IRA, and then merong mga keyboard codes. Yeah. Okay. 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 Medyo sumasakit na yung lalamunan ko, kaya ako ay magi-stop sharing at para naman may share kayo sa hirap, no? Ayan. Magbabasa na tayo. Share. Ginagawa ko lang yun para mabilis yung discussion natin. Ayan. Okay. So, nakikita niyo yung screen. Okay. Keyboard. Okay. Sa right. Okay. Yes po. Nag-comment si ano. Yes po. Maraming mas SSD. Okay. Okay. So, yung ating I/O. Yung ating I/O na external device is a keyboard and then monitor. Ayan. So, tingnan nga natin. Ano yung meron dito sa ating keyboard? Meron siyang International Reference Alphabet, IRA. Pakibasa po yung ating IRA ng keyboard/monitor. Okay. Nasa kalagay sa comment. Di ko makita. Okay. Emad. Pakibasa yung underside IRA.
International Reference Alphabet or IRA basic unit of exchange is the character. Associated with each character is a code. Each character in this code is represented by a unique 7-bit binary code. 128 different characters can be represented. Characters are of two types. One is printable, alphabetic, numeric, and special characters that can be printed on paper or displayed on screen. Two is control, have to do with controlling the printing or displaying of characters. Example is carriage return. Other control characters are concerned with communication procedures.
Okay. So, tingnan niyo yung keyboard nyo, no? Yung ating control characters, yan yung enter. At saka yung nakikita nyo sa taas, yung mga function key, escape, yan. And then yung control, yung FN, yung out, yung caps, no? Yan. So, ang printable, yung pwede kang magsulat ng text, no? So, nakikita nyo naman yung inyong keyboard, no? Yung may number, may letters, ayan. So, ayan, yun ang panagkaiba ng printable, no? Tsaka yung nakikita natin sa ating, no? So, yung ating printable characters, 128 yan, different characters represented, no? And each will has a unique representation of 7-bit binary code. Ayan. Okay. Tapos, yung most common means ng computer user interaction, of course, yung ating keyboard, yung ating mouse, at saka yung ating display. Ayan. Okay. Tingnan naman natin yung ating keyboard codes. Ayan. Sino naman pwede magbasa? Okay. Pakibasa po, Francis Pelias. Francis Pelias. Ayan. Ikaw ba yung walang may problema sa sa audio?
Dinig na po.
Ay, dinig na. Okay, wala na siyang problema. Okay.
Keyboard codes. When the user depresses a key, it generates an electronic signal that is interpreted by the transducer in the keyboard and translated into the bit pattern of the corresponding IRA code. This bit pattern is transmitted to the I/O module in the computer. On output, IRA code characters are transmitted to an external device from the input-output module. The transducer interprets the code and sends the required electronic signals to the output device, either to display the indicated character or perform the requested control function.
Okay. So, ayan. Yung keyboard codes natin, when the user depresses a key, it generates an electronic signal. So, any key na inano natin dito, dinepress, meaning pinindot, no? It will send and interpret by the transducer in the keyboard and translated into a pattern of corresponding IRA code, no? Yun nga yung sinasabi nating IRA, kada character, meron siyang 7-bit binary code na merong 128 characters that can be represented, no? So, ayan. So, nag-output siya through the I/O module, no? Using the IRA code characteristic. Ayan. Ine-interpret siya ng transducer, no? And sends the required electronic signal para makita natin yung print, no? Kung ano man yung ating ipiniprint na text. Ayan. Okay. Next. Ayan. So, these are the major functions for an I/O module. Okay, they fall in the following categories: control and timing, processor and communication, device communication, data buffering, and error detection, no? So, yung I/O natin, para siyang highway, no? Dahil sa kanya dumadaan lahat yan. So, Yan yung pinaka function na nagiging function niya, no? Dun sa ating system, no? Okay? Diyan mo tinitingnan yung control at saka timing, no? It coordinates the flow of traffic between internal resources and external devices. Processor communication, no, involves command decoding, data status reporting, and address recognition. Device communication, no? Okay, kumbaga sa blood vessel ng katawan, yan yung pinaka blood vessel, no? Yan yung pinaka highway, no? And then data buffering, it performs the need for buffering operation to balance device and memory speeds, no? Pati error detection, na-detect niya rin. Para siyang signal, no? Reports transmission error. Ayan. Okay. So, ito yung block diagram ng ating I/O module, no? Dito mula sa interface ng system bus hanggang sa interface ng external device, no? So, yung data lines, dito pumapasok, no? Papasok sa data register, papasok sa I/O logic, and then lalabas dun sa external device, no? Data status, papasok sa external device, no? Papasok sa I/O, lalabas sa address line, no? Yung control lines, papasok sa I/O, no? Papasok sa lalabas sa external device, sa interface logic, yan. Papasok dun sa status or sa control. Ayan. So, ito yung block diagram ng I/O module. Nakikita niyo yung complexity ng external drives, paano siya nagko-control at lumalabas doon sa pasok ng address line, no? Ayan. Okay. So, next, program I/O. So, there are techniques. There are 3 possible techniques for I/O operation, no? Okay, so basahin nga natin. Ayan, okay. Ayan, so basahin nga natin yung 3 technique for I/O operation. Okay, tawagan natin yung hindi pa natatawag ever dahil nasa dulo. Ayan. Si Melrose Ann. Pakibasa naman yung program I/O.
Hello po, rinig po ba?
Yes po.
Programmed I/O. Data are exchanged between the processor and the I/O module. Processor executes a program that gives it direct control of the I/O operation. When the processor issues a command, it must wait until the I/O operation is complete. If the processor is faster than the I/O module, this is wasteful of processor time. Interrupt-driven I/O. Processor issues an I/O command, continues to execute other instructions, and is interrupted by the I/O module. When the latter has completed its work, direct memory access. The I/O module and main memory exchange data directly without processor involvement.
Okay. So, meron dyan 3 technique, no? You have the program I/O, you have the interrupt-driven I/O, and direct memory access, no? Dun sa program I/O, data are exchanged between processor and I/O module. While dun sa interrupt-driven, processor issues the I/O command and continues to execute the instruction and is interrupted by the I/O module when the latter completed its work, no? So, ang pinagkaiba ng dalawa, itong program I/O, yung exchange ng data between processor and I/O module. Dito naman sa interrupt, yung processor ang nag-i-issue ng command, no? Doon sa nag-i-issue ng command and continues to execute the instruction hanggang sa matapos doon sa I/O module. So, yun ang pinagkaiba ng dalawa. Tapos, ito namang direct memory access, nakadirekta yung I/O module at saka yung may direct communication yung I/O module at saka yung main memory exchange, no? So, yung yung processor involvement niya, wala siyang direct without processor involvement kasi naka-direct memory access siya. So, walang involvement yung processor dito sa DMA, no? So, yun yung ating program techniques ng I/O operation. Okay. Next. Ayan. So, ito yung I/O techniques. Yung I/O to memory transfer through processor, no interrupts, that's a program I/O. Use of interrupts, interrupt-driven I/O. Direct I/O to memory transfer, so no interrupts, naka-DMA siya, direct memory access. Ayan. So, okay. Meron naman tayo next, yung I/O commands. Okay. Right. Okay. So, basa ka naman, Kian, Pango.
I/O commands. There are 4 types of I/O commands that an I/O module may receive when it is addressed by a processor. Number 1, control. Used to activate a peripheral and tell what it to do. And tell it what to do. Number 2, test. Used to test various status conditions associated with an I/O module and its peripherals. Number 3, read. Causes the I/O module to obtain an item of data from the peripheral and place it in an internal buffer. Number 4, write. Causes the I/O module to take an item of data from the data bus and subsequently transmit that data item to the peripheral.
Okay, so yan yung ating 4 types ng I/O commands, no? It can either be control, test, read, or write, no? So, yung control, no, ginagamit siya if you would like to activate a peripheral and tell it what to do, no? Pag test naman, if you are you use test in various conditions associated with I/O module or its peripherals. Pwede rin naman if you would like to test something, no? Read, no? Syempre, it causes the I/O to obtain an item data from a peripheral. No? And then write, causes the module, the I/O module to take an item from the data and the data bus and subsequently transmit the data from an item in the peripheral. So, yan yung ating mga I/O commands. Yan yung ginagamit, pinagagamitan ng I/O. Ayan. Okay. Next. So, ito yung ating 3 techniques for input and block data, no? Dito sa nangyayari, ba't naggaganyan? Ayan. Okay. Dito sa next instruction, program I/O, no? Nag-i-start siya sa issue ng read command, I/O module. Papasok siya sa read status, and then mag-i-check status siya, and then read word from I/O module, and then write word in the memory, no? Pagka napasok na yon, no? Done na ba or next instruction? Ayun. Tapos dito sa interrupt driven, no? Nag-i-issue siya ng read. Tapos pagkatapos mag-issue ng read, do something, no? Okay. Balik siya dun sa baba. Done. No? Hindi. Okay, dito ka ulit. Read status ng I/O module, i-check yung status, error ba or ready, and then pasok ka dun sa word, okay, tapos baba sa write, and then magra-write siya, done, yes, yun ang instruction niya. Ito DMA, nakita nyo, wala siyang kadikit, kasi direct memory access siya. Issue read ng block command, read status, ayun, and then next instruction. So, ganun lang yung ano niya. 3 types ng input sa block data. Ayan. And then, you have the I/O instruction. With program I.O., there is a close correspondence between the I.O.-related instruction that the processor fetches from the memory and the I.O. commands that the processor issues in the I.O. module to execute the instruction. Okay, each I.O. connected through an I.O. module is given a unique identifier or address, no? Para siyang nakabus, meron siyang identifier, no? Naka-map siya, no? Memory map I.O., no? So, para siyang taxi na dumadaan sa highway, no? Meron siyang sariling address, no? Kada transaction. Ayan. I.O. mapping summary, no? Ayan. You have memory map and then you have isolated I.O., no? Dun sa memory mapping natin na summary, no? The device and memory state of an address space looks like memory read and write, no? No special command or I.O. There's a large selection of memory access commands available. While the isolated I.O., separate address spaces need I.O. memory select lines and special commands for I.O. limited set, no? So, dun sa address ng memory, naka-share, no? Dito sa isolated, naka-separate yung address, no? Yung I.O., dun sa memory map, naka-read write. Dito sa isolated, yung I.O. Memory, naka-select. Ayan. So, meron siyang special commands dun sa I.O. Dito sa memory command, memory map, no special command. Ayan. Okay. Tapos ito yung ating memory map tsaka isolated I.O. Okay. Sa keyboard input register 516 yung ano niya, register niya. Tapos 517 yung keyboard input status nung control register. Yung I.O. mo, 1 and 0. Ready yung 1, 0 yung busy. No? So, set to 1 and start to read, no? Ito yung address niya. Okay, dito sa ating address ng memory map, no? Okay, yung address niya 200 202, no? Andyan yung instruction, load AC, store AC, load AC, branch C, and then the operand I, no? Okay, magko-comment siya ng load accumulator. Yan. So, ito yung naka-memory map, no? Ayan yung address niya, 200, 202. Dito naman sa isolated, okay, sa isolated, sabi dito, yung memory mo, you need to have a memory select line, no? So, ang select line niya, nasa 200 din, and then 201, no? Ayan. So, ang nag-i-initiate ng comment ay yung keyboard read, no? And check for completion. Ayan. So, naka-test I.O., yung operand 5. Ayan. Dito yung isolated, no? So, this is the memory map of an isolated I.O. Ayan. Isolated memory map and isolated I.O. Ayan. Okay. Interrupt driven. Okay. Interrupt driven. Okay. Medyo sumasakit na ulit ang aking lalamunan. Tatawag na ako ulit. Okay. Si Marian naman. Pabasa po yung interrupt driven I.O. Mary Ann? Mary Ann? Andiyan ka ba, Mary Ann? Mary Ann? Are you there? Class? Naririnig niyo ba ako? O akong wala?
Yes po, ma'am. Rinig po.
Rinig. Okay. Akala ko naputol ako. Si Mary Ann.
Ma'am.
Ayun. Ayun, si Mary Ann. Kala ko ako na yung naputol eh.
Interrupt-driven I/O. The problem with programmed I/O is that the processor has to wait a long time for the I/O module to be ready for either reception or transmission of data.
Tuloy, te.
An alternative is for the processor to issue an I/O command to a module and then go on to do some other useful work. The I/O module will then interrupt the processor to request service when it is ready to exchange data with the processor. The processor executes the data transfer and resumes its former processing.
Okay. Doon sa ating interrupt-driven I/O, no? Kasi nga, ginibigyan siya ng ng ipaprocess, no? Ng processor. Yan lang ang problema niya. You have to wait long time for the I/O module to be ready, no? For the reception and transmission of data. Kasi yan ay dumadaan sa natin. Dinadaanan lang siya ng dumadaan siya sa I/O, no? So ang alternative diyan, yung command sa module, no, i-interrupt siya, no, so that it can do some other useful work, no. Kaya nga meron tayong interrupt driven I/O, no? The I/O module will then interrupt the processor to request the service when it's ready to exchange data with the processor. Yan yung niya, interrupt driven process, no. The processor execute the data transfer and resumes its former processing, no? So yan, para marami kang ma-execute na process. Kaya yung ating mga processor ay interrupt driven. Kasi ini-execute siya ng ating I/O one at a time, no? Hindi man pwedeng sabay-sabay. Ayan. Okay. Next. Okay, so ito yung ating simple interrupt processing, no? From hardware to software, no? Nagsisimula yan sa data controller. Natin ng konti. Ayan. Okay. From the device controller or system hardware issues ang interrupt, then papasok siya sa processor, finishes the execution instruction, and then the processor signal acknowledgement interrupt, and the processor push it to the PC control stack. Ayan. Tapos papasok siya sa processor load. So kita niyo yung interrupt nandyan na, no? Load PC value based on interrupt. Tapos mag-a-act na siya, papasok na siya dun sa software reminder, process information, process interrupt, restore process state information, and then papasok siya dun sa ating restore PSW and PC. Ayan. So yan po yung ating simple interrupt processing. Ito naman, changes in memory and register for an interrupt, no? So sa main memory, na ito yung process ng interrupt occurs at an instruction at allocation, no? Ayan. Ito naman yung isa sa main memory, return from interrupt. Ayan. So from the control stack, no, papasok siya sa control stack, and then sa program counter, and then papasok sa general register. Ayan. And doon sa stack pointer sa loob ng processor, and then babalik interrupt service routine, and then doon sa user program. Ayan. Yan yung process ng return and interrupt occurs in instruction. Ayan. Design issues. Okay, doon sa ating I/O, meron 2 design issues na ini-implement, no? Bakit daw may design issue? Because there will be multiple I/O modules how does the processor determine which device issued the interrupt? Yan. So, if multiple interrupts have occurred, how does the processor decide which one does, no? So, paano raw siya nagde-decide, no? Nagde-decide siya kung ano yung unang issue na nag-arise, no? Kung sino yung nauna. So, first in, first out sa ating I.O., no? Because, there will be almost invariably multiple I.O. modules. So, paano nyo na-determine? First in, first out. Yan. Next, device identification, no? Okay, device identification. Tingnan nga natin. Patulong tayo. Okay. Gusto kong marinig ang boses ni Burn.
Device identification. Four general categories of techniques are in common use. First bullet is multiple interrupt lines between the processor and the I.O. modules. Most straightforward approach to the problem, and consequently, even if multiple lines are used, it is likely that each line will have multiple I.O. modules attached to it. Next is software call. When processor detects an interrupt, it branches to an interrupt service routine whose job is to call each I.O. module to determine which module caused the interrupt, and it is time-consuming. Next is daisy chain or hardware call vector. The interrupt acknowledged line is daisy chained through the modules. Vector, address of the I.O. module or some other unique identifier, and vector interrupt. Processor used the vector as a pointer to the appropriate device service routine, avoiding the need to execute a general interrupt service routine first. And lastly is the bus arbitration or vector. An I.O. module must first gain control of the bus before it can raise the interrupt request line. When the processor detects the interrupt, it responds on the interrupt acknowledged line. Then, the requesting module places its vector on the data lines.
So, yun yung ating device identification, no? So, the four general categories of techniques are in common use. So, ito yung mga ginagamit, no? You have the multiple interrupt lines. That is, thank you. Thank you, sino nga yung nagbasa? Burn. Thank you, Burn, no? So, yung multiple interrupt lines, that is between the processor and the I.O. module. Yung ating software poll. Okay, lipat ko lang para makita ko. Okay, dun sa software poll, no? When processor detects interrupt branches in the service routine. Okay, and then meron tayong daisy chain, no? When the hardware poll is vectored, the interrupt is acknowledged in a daisy chain through modules. And then you have the bus arbitration, naka-vectored din siya. An I.O. module must first gain control of the bus before they rest the interrupt request line, no? So, eto yan, no? So, dito sa ating interrupt controller, okay, yung ating una is multiple interrupt lines. So, dun sa taas, no, you have multiple interrupt lines. And, okay, may software poll ka and daisy chain arbitration, no? So, dito sa ating interrupt controller, the use of 82C59A, ayan, yung Intel, this is an Intel 80386 provides a single interrupt. So, 80386, single interrupt lang siya, no? Dito, no? Then sa A25, it shows the connection of multiple I.O. modules. So, ito, multiple I.O. modules. Base dito sa ating multiple interrupt lines, no? So, multiple. And then, okay. So, minamanage nung 825C5A ang interrupt controller niya, no? Nagpo-prompt siya, programmable, no? Fully nested, rotating, may special must, no? Ayan. Okay. Tapos ito naman yung Intel 8255A programmable peripheral interface. Okay. This is an example of an I.O. module used program I.O. And interrupt driven, no? So this is program I.O. and interrupt driven. Okay. Dun sa ating interface, no? Block diagram. Ito naka-pin layout. Ayan. So programmable I.O. siya. Okay. Tapos ito naman, ito yung control word. Naka-control siya. When the processor sets both A1 and A221, 8255A interprets 8 bits. So, naka 8 bits. 8 bit yung interpretation. Ang transfer niya is 8-bit control word. Since pinag-uusapan natin yung input-output, no? So, ang labas niya is 8-bit control word width per line D2, no? Yan, nakalagay yun sa natin, no? D2. Yan. Okay. So, ito naman yung keyboard display interface. So, ang interrupt niya, request. Ayan, papasok doon. Lalabas dito. From C3, input port. Tapos, output CO1. So, dun sa ating interrupt, no? From keyboard, pasok, and then display, out. Ayan. Keyboard display interface. And then, drawbacks. So, drawbacks of program and interrupt. So, tingnan natin yung drawbacks ng interrupt-driven I.O. Ayan. Pakinggan natin si Mark Edison. Mark Edison, pabasa yung drawbacks.
Drawbacks of program and interrupt-driven I.O. Both forms of the I.O. suffer from the two inherent drawbacks. The I.O. transfer rate is limited by the speed with which the processor can test and service a device. A processor is tied up in managing an I.O. transfer. A number of instructions must be executed for each I.O. transfer. When large volumes of data are to be moved, a more efficient technique is direct memory access or DMA.
So, sinasabi dito, para hindi masyadong mahirapan yung natin, yung ating processor. Okay? Kasi nga dun sa ating I.O. transfer, yung rate limited dun sa speed ng processor, no? So, when we are doing a large volume of data, mas maganda yung efficient, yung direct memory access kaysa yung nakagamit tayo dun sa palagi sa processor. Although, kahit naman tied up yung processor, yung managing ng I.O. transfer, dun sa number ng instruction, na-execute naman siya. Hindi nga lang ganun kabilis, no? Pero, yun nga, yun yung pinag-uusapan na drawback ng interrupt-driven at saka program I.O. Kaya, mas maganda talaga gumamit na lang ng direct memory access. Kung gusto mo ng mas mabilis. Ayun. Okay. Right. So, ito yung ating typical DMA block diagram, no? From here, we have data count, data register, address register, and then control logic, no? Dun sa data lines, no? From here to here yung ano sa data, and then address line, dun tayo papasok sa register. And then dun sa control logic, no? Dun nagre-request ng direct memory access, ina-acknowledge yung direct memory access. Diyan din yung interrupt, read, at saka write, no? Ayan. So, ito yung ating typical DMA block diagram. Direct memory access. Ito naman yung direct memory access na interact breakpoints during an instruction cycle, no? So, pwede siyang dun sa instruction cycle natin, pwede siyang mag-fetch, mag-decode, mag-fetch, operand, mag-execute ng instruction, no? Okay. Ito yung ating breakpoints, DMA breakpoints, and then ito yung interrupt breakpoint, no? Dun sa ating processor cycle, no? Andito yung result, dito yung process. Ayan. So, dito umiikot yung yung instruction cycle ng DMA at saka interrupt breakpoints. Now, this is now the alternative DMA configuration, no? Pwedeng mula sa memory, no? Ipaprocess ng IO, tapos papasok sa DMA and then processor. Pwede namang processor, DMA, IO, and then ipaprocess ng IO, pasok sa memory. So, this is single bus detached DMA. Pwede ring single bus integrated DMA, no? So, from processor, papasok sa DMA, pasok sa IO, no? Another DMA, may IO rin dito, and then pupunta sa memory, no? So, meron siyang integrated DMA, no? Naka-integrate yung DMA mismo. And then you have a system bus, and then you have an IO bus, no? So, ito yung mga alternative DMA configuration. Ayan. DMA usage of system bus. Okay, so ito yung ating data bus, no? Yan yung umiikot para magbasa, nagbibigay ng andyan yung addressing, papasok sa memory, no? Tatakbo, iikot, no? Papasok sa DMA, lalabas sa HRO, no? Hold request, HRQ, hold request, HLDA, hold acknowledge. So, i-acknowledge yung DMA. Tapos lalabas. Papasok uli. Ayan. Yan yung takbo natin sa Pansin nyo, nakahiwalay siya sa CPU, no? Kasi nga, ito ay direct memory access. Flyby DMA controller. Now, ano naman yung flyby na yan, no? Itong flyby DMA controller, data does not pass through and is not stored in the DMA chip. DMA only between IO port and memory and not between two IO ports or two location. Can do memory to memory via register, and then DMA channels program independently anyone active numbered 0, 1, 2, 3. Ayan. So, yan yung flyby DMA controller. Okay, so dito sa ating Intel 8237 na register, ito yung ating command processor status mode at saka single and all mask, no? Sa DO, meron kang memory to memory, channel is 0, reach at TC, and then sa mask, clear set, no? Ayan. So, ito yung ating mga controller, no? Under dun sa 8237A register, no? Okay. Okay. And then, ito naman yung direct cache access. Dito sa direct cache access, yan, yung DMA is not able to scale. It demands, demand is coming primarily widespread in the deployment of 10 GPS and GPS Ethernet switches. No? Ayan. Another source of traffic comes from Wi-Fi and a gigabit range. Network Wi-Fi device that handle 3.2 GPS and 6.7 GPS are becoming widely available and producing demand on enterprise system. Ayan. Yan yung sa ating direct cache access. Ito naman yung Xeon E5 2600 4600 chip architecture. So ito yung architecture niya. Okay. So ito yung core, meron siyang 1 2 3 4 1 2 3 4 7 down na core. Actually 8. Nag-start lang siya sa 0, no? Meron siyang 8 na core. Tapos yung memory control hub na sa gitna. So and dito yung ating cache. Puro L3 na cache. 8. 1 2 3 4 5 6. Okay. L1, L2. Ang output niya sa L1, naka-assign yung ano niya, 64. Yung L2, mas mabilis, 256. Ganon din dito sa kabila. So, ang ano niya is QPI, PCIe. Okay. D2, DDR3 memory. No? Ito yung ating chip boundary. This is a Xeon E526 4000 chip architecture. Intel Xeon. Xeon E5. Ayan. Okay. And then, ito yung mga cache-related performance. Tingnan nga natin. Pwede bang magbasa para may katulong ako? Pakinggan na natin si Ken Nokum. Ken.
Hello, rinig po.
Yes.
Ayos po. Network traffic is transmitted in the form of a sequence of protocol blocks called packets or protocol data units. The lowest or link level protocol is typically Ethernet, so that each arriving and departing block of data consists of an Ethernet packet containing as payload the higher level protocol packet. The higher level protocols are usually the Internet Protocol or IP, operating on top of Ethernet, and the Transmission Control Protocol or TCP, operating on top of IP. The Ethernet payload consists of a block of data with a TCP header and an IP header. For outgoing data, Ethernet packets are formed in a peripheral component such as I/O controller or network interface controller or NIC. For incoming traffic, the I/O controller strips off the Ethernet information and delivers the TCP or IP packet to the host CPU.
Ayun, okay. So, dito sa ating cache-related performance, ayan, yung ating network traffic, natatransmit siya in the form of sequence, no? So, yung sequence, protocol blocks, and packets of protocol data, no? Yung ating lowest or link level protocol is typically naka-Ethernet, no? Ethernet siya, so nag-a-arrive siya departing from block and consist of naka-Ethernet packet, no? So, yung payload niya, higher dun sa level ng protocol packet. The higher level protocols are usually yun sa IP, no? Internet protocol. On top, yung Ethernet, no? Yung transmission ng TCP, Transmission Control Protocol. No? Nag-ooperate siya sa ibabaw ng IP, ng Internet Protocol. Yung Internet payload, nagko-consist siya ng block of data dun sa TCP header at saka IP header, no? So, ang outgoing data, Ethernet packets, and they are formed in a peripheral component. Tapos, yung I/O controller, naka-NIC, yung Network Interface Controller. Ayan. And for incoming traffic, yung I/O controller, ini-strip niya yung Ethernet information, tas dinideliver siya ng TCP/IP jack packet and host CPU. Yan yung ginagawa nyo. Pwede nyong i-assign yung dinadaanan ng inyong TCP/IP packets, no? Pwede nyo siyang i-assign. Halimbawa, mag-host kayo ng space sa web, no? So, isi-set nyo siya sa, halimbawa, yung inyong SAMP, no? Yan, isi-set nyo kung anong TCP/IP packets ang dadaanan niya. Yan. Halimbawa lang, no? Yung SAMP na space na gagamit dun sa traffic, no? Yung system na SAMP, no? Nakagamit na ba kayo ng SAMP? Or PHP? Nakagamit na kayo yung SAMP or PHP? Di pa? Hindi kayo hindi nyo pa nagamit yung
Hindi po.
Di pa. Okay. So, yung mga web-based na app, pwede nyo i-assign yung niya, yung dadaanan niya na host dun sa TCP/IP. Ayan. Okay. Okay. Ayan. Cache-related issue performance. Okay. So, ito yung issue niya, no? Doon sa ating DMA, the scheme when the application wish to transmit data, it places the data in an application assigned buffer in the main memory, no? The core transfer to the system built buffer in main memory and creates necessary TCP/IP headers. The packets is then picked up in the DMA, transferred to the NIC, and this activity engages not only main memory but also cache. Similar transfer between system and application buffer are required for incoming traffic. For both outgoing and incoming traffic, the core main memory and cache are all involved. So, yun lang. Pagka involved na silang lahat, bumabagal. Yun yung niya, issue niya. So, magkakaroon ng performance issue. Okay. So, this is the packet traffic steps, no? Sa incoming, you look at packet drives, DMA, NIC interrupts, retrieve decryptors and headers, cache miss occur, and header is processed, payload is transfer. So, that is incoming. Sa outgoing, you have packet transfer requested, packet created, output operation invoke, DMA transfer, NIC signal completion, and then driver freeze buffer, no? Ito yung mga packet traffic steps para sa ating I/O, no? Okay. Then you have here the direct cache access strategy. Okay. Okay. So, basahin natin. Asa na si... Kayo naman magbasa. Ayan. Okay. So, siguro pwede nating pakinggan si Ken. Marinig ko naman ang boses ni Ken. Ken Layug.
Direct ka sa simple strategy was implemented sa prototype ng Intel CM para research between 2006 and 2010. This form of DCA applies only to incoming network traffic. The DCA function in the memory controller sends a prefetch into the core as soon as the data is available in the system. This enables the core to prefetch the data packet to the system buffer. Ito to much more substantial gains can be realized by avoiding the system buffer in main memory altogether. The packet and packet descriptor information are accessed only once in the system buffered by the core. For incoming packets, the core reads the data from the buffer and transfers the packet payload to an application buffer. It has no need to access the data in the system buffer again. Cache injection and implemented in Intel's Xeon processor line referred to as direct data IO.
Okay, so ito yung direct cache access strategy, no? So, para raw simple yung strategy na i-implement do sa prototype. Dito sa Intel Xeon processor between 2006 to 2010, nag-form sila ng this form of DCA, direct cache access, okay, applies only to incoming network traffic. So naka-apply lang siya sa papasok na network traffic. So yung DCA nagpa-function siya in the memory controller and send it pre-fetch to the core, no? This enables the core to pre-fetch the data packet in the system buffer, no? And mas malaki daw yung gain niya, and it realizes avoiding the system buffer in the main memory. So yun yung ano niya, no, yung gain niya, no? The packet and packet descriptor information are accessed only once in the system, no? The incoming packets in core reads the data and the buffer transfer the packets via payload. It has no need for access of the data in the system buffer again. So one time siya. Okay, so yan po yung ating paggamit dun sa Xeon ng direct data IO. Ayan, as direct data IO. Mas maganda siya, no? Yung system buffer, hindi siya masyadong gamit na gamit, no? Mas mabilis. Ayan. Okay. So, ito po yung ating comparison ng DMA at saka DDIO, no? DDIO is Intel Direct Data IO. Intel Direct IO. Direct Data IO, no? It is implemented on all Xeon E5 family of processors. So, mga processor ito, no? Dito sa comparison ng DMA, normal DMA transfer to memory, ito yung DDIO transfer to cache. So, last level cache, last level 3. 3 ang pasok niya. 1, 2, 3, 4. 1, 2, 3. Mas mabilis dun sa DDIO ang pasok sa cache kaysa sa DMA. Dito sa normal DMA transfer, 1, 2, 3, no? So, dun sa main memory, ang pasok agad, tapos papasok sa cache 2, and then lalabas dun sa IO controller. Dito sa DDIO, 1 mula sa core, tapos pasok sa labas. So, dalawa. Ibig sabihin, mas mabilis yung DDIO kaysa dun sa, sa DMA. Ayan. Evolution of IO function. Okay. Tawag tayo. Ayan. Okay. Tawagin natin si Lance. Lance Tristan Bautista.
Hello. Evolution of the IO function. The CPU directly controls a peripheral device. Number 2, a controller or IO module is added. The CPU uses programmed IO without interrupts. 3, same configuration as in step 2 is used, but now interrupts are employed. The CPU need not spend time waiting for an IO operation to be performed, thus increasing efficiency. Number 4, the IO module is given direct access to memory via DMA. It can now move a block of data to or from memory without involving the CPU, except at the beginning and end of the transfer. 5. The I/O module is enhanced to become a processor in its own right, with a specialized instruction set tailored for I/O. Number 6. The I/O module has a local memory of its own, and it is in fact a computer in its own right. With this architecture, a large set of I/O devices can be controlled with minimal CPU involvement.
Okay, so yung evolution niya, mula 1 hanggang 6, no? Sa 1, CPU directly controls the peripheral device, no? Sakita niyo yung ano niya, yung process ng evolution, no? Yung improvement, no? So, nagle-less yung access dun sa CPU, no? Dito sa controller number 2, yung I/O module na-add siya dun sa CPU, and CPU is program I/O without interrupt, so walang interruption, no? Same configuration as in step 2, but now the interrupts are employed and CPU need not to spend time waiting, no? So yung processing mas nag-improve yung performance, nag-increase yung efficiency, no? Dun sa number 3. Dun sa number 4, progressing tayo, yung I/O module, given the direct access, yung DMA, no? Yung memory without involving the CPU. So, from end to beginning, no? Nagle-less yung access dun sa, sa CPU, no? And then, dun sa number 5, yung I/O module natin, na-enhance siya, and become a processor on its own. So, nagkaroon siya ng processor on its own, nagkaroon ng specialized instruction, naka-tailored dun sa I/O. And then 6, yung I/O module has local memory, no? Nagkaroon siya ng local memory dun sa I/O mismo, no? And then with this architecture, large set of I/O devices can be controlled with minimal CPU involvement. So from being CPU directly controls dun sa 1, sa 6, minimal na yung involvement ng CPU. So, nag-evolve yung ating I/O. Okay. Sorry. Hanggang oras tayo? Alas 4 or 4:30?
Yeah, 4:30.
4:30. Okay. Okay, so ito yung ating I/O channel architecture. Ayan. So, data address channel to main memory, papasok sa selector channel, no? Meron tayong control signal path ng CPU, no? Ayan yung I/O controller, no? Meron siyang diretsong signal path sa CPU, no? CPU dun sa ating selector A, no? Dito naman sa ating multilexor, no? Ganun din, yung control ng signal ng CPU, ayan yung path, no? Naka-multiplexor channel. So, ibig sabihin, maraming I/O, no? Mayroong I/O dito, may I/O dito, may I/O dito, may I/O dito, no? So, ayan yung multilexor, no? Okay. And then, you have universal serial bus, USB. Ayan. USB na tayo. Okay. Pakibasa nga po yung ating USB. Okay. Sino pa ang hindi ko natatawag? Si Rosella May Legaspi. Okay.
Universal Serial Bus, USB. Widely used for peripheral connections, it is the default interface for slower speed devices. Commonly used high-speed I/O, has gone through multiple generations. First is USB 1.0, which defined a low-speed data rate of 1.5 Mbps and a full-speed rate of 12 Mbps. USB 2.0 provides a data rate of 480 Mbps. USB 3.0 higher speed bus called super speed in parallel with the USB 2.0 bus. Signaling speed of super speed in 5 Gbps, but due to signaling overhead, the usable data rate is up to 4 Gbps. USB 3.1 includes a faster transfer mode called Super Speed Plus. This transfer mode achieves a signaling rate of 10 Gbps and a theoretical usable data rate of 9.7 Gbps. Is controlled by a root host controller which attaches to devices to create a local network with hierarchical tree topology.
Ayan. Okay, tanong lang. Ano na yung latest ng natin, yung USB na ginagamit? Ano yung transfer rate na alam ninyo? Diba meron tayong mga version ng USB ngayon? Ano yung latest na yun? 3.1. 3.1, ma'am. Okay. So, yun na yung latest. May 3.2. Tingnan na natin yung So, mabilis na talaga, no? Dati, 1.0 yung USB, no? Tingnan natin kung anong pinakamabilis na transfer rate. USB. Latest USB version. All. May 4.0 na, USB. The latest iteration was announced August 29. August 29. Pero yun sa mga binibenta sa na mga USB. Ano yung speed na para kasi yung gamit ko dito nasa 3 lang 3 point something. So meron na palang 4. 3.2 sabi ni 3.2 yung Kingston USB Plus Generation 3.1 meron siyang 3.2. Sino yung nagsabi ng 4? Ano tong 4 na to? USB Generation Electro Pages Universal Bus 4.0 iteration announced in August. Oh, USB version. Meron na raw Kung meron na nung 2019, ibig sabihin umiikot na to. Pero yung ba mga USB nyo, anong mga gamit nyo dyan? Ano ba mga gamit nyo, class? No, sa ating USB. Ako nasa 3.1 yung gamit ko dito ng mga USB. Yung mga 1 tera 1 terabyte na na USB. Anong speed nun? Usually hindi naman siya mag 1 tera kung lang Kailangan mataas ang speed nun dahil malaki yung isasalpak na na entry ng data. Okay, basahin natin yung mga nagko-comment sa Ayan, 3.2 si Ken. Si Ace 3.1, ma'am. Ayun. So, yan yung latest ngayon. Okay. Right. So, okay, balik tayo dun sa ating discussion. And then, itong Firewire. Yan nga, sabi 4 GPS. Reusable. Yan. So, Firewire serial bus. Parang hindi ito masyadong gamit na gamit. Firewire serial bus. Tingnan natin itsura nito. Firewire serial bus. Ito, RAID. Firewire. Firewire serial bus. Yung ganon. Yung pin ay kakaiba. Image. Ayun. Nakaganito. Ito yung tsura ng firewire. Dito masyadong, no? Hindi siya masyadong familiar. Hindi ko to masyadong ginagamit. Ibang niya, ibang connection. Hindi siya parang HDMI na kakaiba ang itsura. Kaya itsura. Hindi siya iba yung niya. Iba yung connection niya. Okay. Right, basahin natin tong firewire. Ayan. So, okay, tawag tayo. Pakinggan natin si Rogelio Collis. Rogelio Collis. Rogelio Collis. Hello? Ma'am, wala po ako mic. Sensya na po. Okay. Okay, fine. Oh, kailan ka magkaka-mic? Magka-mic na. Para kasama ka sa discussion. Okay. Si Juan Paulo Manicar.
Yes po, ma'am.
Firewire.
Firewire. Babasahin.
Yes.
Firewire serial bus was developed as an alternative to Small Computer System Interface or SCSI to be used on smaller systems such as personal computers, workstations, and servers. Objective was to meet the increasing demands for high I/O rates while avoiding the bulky and expensive I/O channel technologies developed for mainframe and supercomputer systems. IEEE Standard 1394 for a high-performance serial bus uses a daisy chain configuration with up to 63 devices connected off a single port. 1022 firewire buses can be interconnected using bridges. It provides for hot plugging, which makes it possible to connect and disconnect peripherals without having to power the computer system down or reconfigure the system. Provides for automatic configuration and no terminations, and the system automatically performs a configuration function to assign addresses.
Ayun. So itong firewire, they would like to introduce yung I/O rate na mas malaki yung demand, no? Katulad nung sa server at saka sa mga workstation. So nag-introduce sila ng firewire para daw yung mas mabilis yung interconnection ng bridges, no? So hot plug siya, meaning mas mabilis ang transfer at yung power hindi mo na kailangang i-reconfigure, no? Meron siyang automatic configuration, no? No termination, and system automatically performs configuration function. So naka-autonomic yung niya, no? Yung paggamit nitong firewire na to. Ayan. Okay. So ganito yung niya ganito yung itsura niya. Saan na yung firewire na yan? Ayan, share. Okay. Para siyang HDMI. Pero not necessarily. Ayan. Ito. Para siyang mukhang network pin. Pero actually firewire siya. Ito yung mga lumabas nung dun sa mga external hard drive. Ganito yung ano niya, connection niya, firewire. Yung bang mga unit nyo, meron ba kayong firewire? Yung aking unit, walang firewire eh. Pero, yung mga laptop nyo, meron ba kayong firewire dyan? Pero meron akong HDMI. Kasi lumang ano na to eh. Wala nang masyadong firewire dito. Tingnan ko nga kung meron akong ano. Tingnan nyo nga yung mga unit nyo kung may mga firewire dyan. Alis ka dyan. Saan yung aking... Saan ko nga ito? May firewire ba ako dito? Wala eh. USB at saka HDMI at saka yung... Wala siyang firewire. Hindi na uso kasi to eh. Ayan. Pang server type to eh. Hindi siya pumatok nung nung lumabas to. Kasi masyadong bulky. Anyway, so yan yung ating firewire. Okay. Next. SCSI. Yung SCSI natin, it's a small computer system interface. So, ganun yung itsura niya, oh. Ayan. So, basahin mo nga yung ating SCSI. Stop sharing. Balik ako dito sa ating window. Ayan, share. Okay. Basa nga, Kuya Matt Jean Antonio. Yung ating SCSI.
Yes, nakuha ito ba?
Sige, diretso. Basa.
SCSI, Small Computer System Interface. A once common standard for connecting peripheral devices to small and medium-sized computers. Has lost popularity to USB and firewire in smaller systems. High-speed versions remain popular for mass memory support on enterprise systems. Physical organization is a shared bus which can support up to 16 or 32 devices, depending on the generation of the standard. The bus provides for parallel transmission rather than serial, with a bus width of 16 bits on earlier generations and 32 bits on later generations. Speeds range from 5 Mbps on the original SCSI 1 specification to 160 Mbps on SCSI 3 UP.
Okay, so yung SCSI, no? That is a small computer system interface, no? A once common standard connecting peripheral device for small, medium-sized computer. Etong SCSI na to, na last time nakakita ko nito sa printer, no? Yung maingay na yan, no? Yung SCSI niya, yung speed niya medyo maingay lang ng konti, no? So nag-aano siya ng serial port, parallel transmission, no? Meron siyang 16-bit, minsan 32-bit, no? Itong mga SCSI na to, yung peripheral device na yan, nauso yan dun sa mga small, medium size computers, no? Ayan, dun sa mga server type, no? Pero last time nakakita ako nito, yun nga sa mga printer, no? Yung pin na yan, no? SCSI. Okay. Again, hindi siya masyadong gamit. Ang ano natin is, ang pumatok talaga is yung USB eh. Napaka-portable niya kasi. Ayan. Then you have Thunderbolt, the most recent fastest peripheral connection technology to become the general purpose use, developed by Intel and collaboration with Apple. Okay. The technology combines data, video, power, audio in a single high-speed connection. Tapos yung peripheral niya meron siyang hard drive, naka-RAID, meron siyang video capture box, meron siyang network interface. Ayan. So it provides up to 10 GPS throughput in each direction and up to 10 watts of power to connected peripherals. Ayan. Thunderbolt. Ano ba yan? Thunderbolt. Okay. Tingnan nga natin tong Thunderbolt na to. Thunderbolt port. Aray ko. Thunderbolt. Thunderbolt. I-O. I-O. Oh. Ayun, yung may nakalagay na ano. Nakashare ba ako, class? Nakashare ba ako? Hindi.
Yung PPT po, ma'am.
Yung PPT. Teka, sandali. Ito yung ano, makikita nyo yung Thunderbolt. Meron siyang thunder talaga. Meron siyang thunder na ano, na itsura. Yan. Yung sa ating Thunderbolt. Yan o. Yung nakalagay. May nakita na kayong ganitong ano, ganitong I/O port. Ayan. Si Apple at saka si Intel. Naka-Thunderbolt. Nito ko lang nakita to eh. Gumagamit lang siya ng ano. Ilan ba lang itong ginamit? Thunderbolt. Teka. Okay. All. Thunderbolt interface. Intel. Saan siya inilagay? PCI. Ayun, DMA niya. Descriptors. Meron siyang 20 na pin. Ayun, ang cables niya. May nakalagay na Thunder. Ayan. Graphic subsystem. Thunderbolt 1 and 2 port. Mukha siyang, para siyang USB. Okay, Thunderbolt 3. Iba yung port niya, no? Yan, no? Yung itsura. USB-C. USB-C. So, naka-USB rin siya. Pero, yung connector niya, iba sa itsura ng ano. Okay. So, mabilis daw yan, no? Mabilis daw yung Thunderbolt na yan, no? Meron siyang sariling hard drive, mini hard drive dun sa peripheral, naka-RAID. Nag-video capture boxes siya. So, this is a technology collaboration between Intel and Apple. Ayan. Then, you have InfiniBand. Itong InfiniBand, okay, tawag nga tayo. Medyo masakit yung lalamunan ko. Pwedeng pabasa po, Mr. Joseph Olivar. I-stop sharing ko, syempre. Dahil mas madali pagka dito. Yung pong InfiniBand. Okay.
Hello po.
Yes.
Rinig po ba ako?
Yes.
So, InfiniBand. I/O specification in that high-end server market. First version was released in 2001. After this, heavily relied on by IBM Z Enterprise series on mainframe. Standard describes as an architecture and specifications for data flow among processors and intelligent I/O devices. Fifth has become a popular interface for storage, area networking, and other large storage configurations. Next is enable servers, remote storage, and other network devices to be attached in central fabric of switches and links. Whereas is a switch-based architecture can connect up to 64,000 servers, storage systems, and networking devices.
Okay. So, eto, high-end server base yung ano niya, yung IO, itong IO na InfiniBand, no? So, ang itsura niya, InfiniBand. Tingnan natin sa, teka, syempre, kailangan kong i-share yung screen ko. InfiniBand. InfiniBand. Meron pang fiber channel, no? InfiniBand images. Okay, ito yung InfiniBand. Parang yung connection sa network. Naka-InfiniBand. Ito. Mellanox. Yung sa switches, naka-InfiniBand. Ayan. InfiniBand. Ganyan yung tsura niya. Again, mukha siyang USB. Pero actually, hindi. Ano? Okay. So, ganito yung pasok ng InfiniBand. Ganito yung connection niya. Ayan. So, naka-server type siya. No? Ayan. Stop sharing. Balik tayo doon sa InfiniBand. So, yung medyo mataas yung ano nito, no? Mataas yung specification niya dahil ang takbo niya is from processor to I/O devices, no? So, kung ang storage area mo ay medyo malaki yung configuration, ayan, InfiniBand yung ano niya. So, it enables servers and remote storage and network devices. So, ang capacity niya, pwede siyang mag-connect up to 64,000 servers, no? Connect storage system. Nakita nyo nga yun, dun pa lang sa network eh. Itong network device na to. No? Para siyang switch ni Cisco. Ayan. Siyempre, hindi ako nakashare. Sorry naman. Okay. Siyempre, salita ako ng salita eh. Hindi ko naman sinishare yung sinasabi ko. Ayan. Yung ating network device. Ayan. Yung switch. Yung switch na to. Ayan. Para siyang switch. No? So, pwede siyang mag-connect ng 64,000. No? Ganon siya kadami. No? Switch. Network switch. Ayan. Okay. Balik tayo dito. Stop sharing. Okay. Right. Entire screen. Hindi. Bakit entire screen? Cancel. Hindi entire screen. Okay. Alright. So, that is InfiniBand. Ayan. And then, you have PC Express and then SATA. No? Yung SATA, yan, normal na naririnig natin yan. Serial Advanced Technology Attachment, and then PCI Express, high-speed bus system for connecting peripherals for a variety of speed. No? Ayan. So, yung SATA, yung speed niya up to 300 Mbps. Widely used in desktop computer. So, it's an interface for this storage system. Ayan. Then, you have your Ethernet, yung ating port. Yan sa ating LAN. No? Yung ating pagkoconnect ng LAN. No? Ayan. Okay. And then, you have Wi-Fi. So, Wi-Fi, wireless yan. No? Magamit ng public hotspot. Ayan. So, dun sa ating Ethernet, wired yan, no? Predominantly wired. Yung rates ng support ng up to 100 Gbps. Essential siya para sa ating mga workstation para i-connect yung ating LAN system. Nagbigan siya experimental 3 Mbps system na bus, no? And then nag-move siya sa bus-to-bus switch, no? Yung data rate niya periodically increase in order of magnitude. Tapos nagkaroon siya ng central switch. Ayan. And then Ethernet system currently use up to 100 speed of GPS. Ayan. Then Wi-Fi, no? Okay, itong Wi-Fi, sige, basahin nga natin. Okay, Wi-Fi. Pakinggan natin si tawag ko na to si Melrose. Wilbert de los Santos.
Wi-Fi is the predominant wireless internet access technology. Now connects computers, tablets, smartphones, and other electronic devices such as video camera, TVs, and thermostats. In the enterprise has become an essential means of enhancing worker productivity and network effectiveness. Public hotspots have expanded dramatically to provide full internet access in most public places. As the technology of antennas, wireless transmission techniques, and wireless protocol design has evolved, the IEEE 802.11 committee has been able to introduce standards for new versions of Wi-Fi at higher speeds. Current version is 802.11ac 2014 with a maximum data rate of 3.2 Gbps or Gbps per second.
Okay. So, yung ating Wi-Fi, yung latest daw is 3.2, no? So, yung niya is 802.11ac, no? Yan yung maximum rate niya, no? Ang maximum rate niya is 3.2 Gbps, no? So, ganun nakabilis ngayon yung ating yung ating Wi-Fi, no? Kung gusto nyo makita kung gaano kabilis yung Wi-Fi ninyo, pwede kayong mag speed test, no? Check nyo nga yung speed test nyo, no? Tingnan nga natin. Sige, mag-test tayo ng speed stream. Tingnan ko kung gaano kabilis para makita ko rin kung sakto ba yung binibigay sa akin ng PLDT speed test. Run ko lang, no? Go. Okay. Bagal naghahanap pa ng Teka. Converge. Okay, 300 Mbps to saan siya na magpa-plateau? Ayun. Nag-plateau siya sa 196.82 Mbps. Okay. Tapos yung upload niya ay ayan 215 Mbps. Ayan. So sa inyo, kumusta yung natin? Yung ng signal nyo dyan ng wireless? Anong ini-emit niya? Tingnan ko nga. Stop sharing. Ano yung speed ng internet niyo? 27 sikit. Sige nga, sulat nyo nga yung inyong mga speed dyan. Lagay nyo nga sa comment. Ayan. At ating babasahin. Ating wireless. Okay. 55. Yan bang mga speed nyo na yan ay Hindi busy yung ano nyo ha, wala kayong ibang niraran. So, ano yan, naka-ano kayo, naka-prepaid or binabayaran nyo na monthly katulad dun sa akin? Tanungin natin itong si Jericho. Jericho, ano yung 73 Mbps? Yung binayaran mo lang today or meron kayong binabayaran na monthly?
Monthly po ba?
May monthly. So, yung monthly nyo magkano?
I think yung plan ko namin sa Sky is 1.5.
1.5? Tapos 73 lang yung Mbps?
Marami din po kasi gumagamit sa bahay.
So distributed na yung 73. Okay, 73. Etong kay Matt, yun sa'yo, yung 75.
Ano po, 2.5 per month po.
2.25. So, ibig sabihin marami rin kayong gumagamit. Distributed na to.
Yes po.
Okay. So, buong pamilya tong gamit. Tapos, 2.5. Kasi ako dito sa PLDT, although dito sa compound namin, dami nakakonect. Ako, dami ko rin devices. Pero yung inano ko kanina, ako yung main na nakakonect. Kaya yung ano sa akin is around 200. Tsaka yung mga gumagamit ay hindi pagising. So, namayang panggabi ko-connect na yan. So, mababawasan na yung ano ko. Pero, yung binabayaran ko sa 1.7 ay binibigyan ako. Actually, naka-assign sa amin ay 25 Mbps. Pero dahil dito sa location namin, wala pang masyadong gumagamit. Yung bato sa akin, ako lang yung dito sa area ng actively gumagamit ng internet. Kaya kahit na ang binabayaran ko lang is 25, minsan umaabot sa sa 200. Kumbaga dito sa highway na to, ako lang yung gumagamit. Nagagamit ko lahat yung binibigay sa akin ni PLDT. So, sulit na sulit yung yung bayad ko. Labis pa yung ibinibigay sa akin ni PLDT. 200 Mbps. Ayan. Okay. So, yun yung ating Wi-Fi, no? Yan, sa ating wireless connection, no? So, gumagamit siya ng 8.2 11 AC, no? Dun, yung version ng 2014, yun na raw yung latest, no? Okay, ang maximum data rate niya is 3.2 GPS. So ito yung ating channel subsystem structure, no? Okay. Okay, hindi ko mababasa dahil kakaiba yung iba yung sinulat, no? Siguro nagkamali ng lagay. So, ito yung ating partition. Meron tayong sub-channel. Channel subsystem. Nakalabas dito sa channel, no? Partition. Pinartition. Ito yung para sa IBM EC12IO, no? Ayan. Okay. So, ito yung IBM ZEZ 12IO frames front view. Okay, so andyan yung power supply, ito yung internal batteries. Okay, ito yung mga processor books, memory, InfiniBand, naka-InfiniBand siya. Tapos PCIe and water. N plus water cooling units, meron siyang cooling units, PCIe drawer. Yan, support elements. Power supply. Meron din siyang power supply. Ayan. Tapos ito yung system structure. Ayan. May InfiniBand. Ayan. So, yan yung ating chapter 7. So, na-discuss na natin yung I/O, input, output, no? Yung external devices, I/O modules, program I/O, direct memory access, interrupt-driven I/O, direct cache access, and then I/O channels and processor. Okay, moving on. Yes. Okay. Dito na tayo kay operating system support. Ayan. 53. Okay. Operating system support. Okay. Panoorin natin yung ating operating system support na video. Ayan. Teka lang.
Now, what's an operating system? Well, it's a layer of software that provides two important services to a computer system. It provides abstraction and arbitration.
Operating system. Okay.
Abstraction means hiding the details of different hardware configurations so that each application doesn't have to be tailored for each possible device that might be present on the system. Arbitration means that the operating system manages access to...
Wait lang, nakikita nyo ba yung sineshare ko? Hindi, ano? Yan na naman tayo. Okay, operating support. Ayan, chapter 8 na. Ayan, share. Ulit. Siyempre, kailangan makita nyo yan.
Shared hardware resources, so that multiple applications can run on the same hardware at the same time without interfering with one another. Now, these hardware resources that need to be managed include the CPU, the hierarchy of memory, all the input-output devices on the system, and to some degree, the power and system management features of the system. Many of these features are handled directly by the hardware, but the operating system is involved, particularly in energy conservation. Now, the abstraction features of the operating system allow hardware devices manufactured by different manufacturers to have the same interface within software for applications to use. These hardware devices all have different low-level instruction sets. They all have particular capabilities, features, and details that are unique to each hardware device. If we didn't have a common interface into these hardware devices, first of all, our variety of hardware might be limited. But worse, every application on the system would have to be programmed to use every single device on the system. An example, back in the 1990s, computer games often required internal programming for specific video cards and specific sound cards. It was often necessary to go into the settings for each game and tell the game what type of video card you had, what type of sound card you had, for the purpose of configuring the game to use that particular hardware. Imagine if that had to be done for every single application on the system, including, say, a calculator or a web browser. That would be a very untenable situation in terms of being able to make use of computers the way we use them today. Also, what if we could only run one program at a time on a computer system? Years and years ago, that was the case. However, our modern system is running multiple applications simultaneously, and it's up to the operating system to ensure that all these applications can access resources. So each CPU is divided among the different programs, each program gets access to memory, input-output, as well as disk, and in an ideal world, the operating system also enforces policies that isolate applications from each other, so that a crash in one application doesn't take down the entire system or other applications. Now, of these examples, do we have a situation where we have abstraction or arbitration? Well, first example supporting both Intel and AMD processors. This is an example of abstraction. We don't have to write separate software for an Intel processor relative to an AMD processor, at least for 99.99% of applications. Simply write the application once, it will run on either processor. Switching between applications is an example of arbitrating hardware resources among the different applications on the system. Separating memory allocated to different applications is also an arbitration activity. It keeps one application from overwriting the contents of memory that's being used by another application. Enabling video conferencing software to use different camera devices. This would be an example of abstraction. The video conferencing program just has to know how to use a camera interface that the operating system provides, and then different cameras from different manufacturers can be used without having to write the application, the video conferencing program, to be able to talk to each individual camera. Similarly, accessing two different hard disks from two different manufacturers. Any underlying detailed differences between those drives can be handled by using the operating system to abstract away the details. Sending and receiving messages over a network is both abstraction and arbitration. On the one hand, we're abstracting away the details of each particular network card to be able to send and receive the message. On the other hand, we're sharing that network card among all the different applications on the system. Now, we can think of the system in terms of layers. At the bottom of the layer cake, we have the hardware. This is what executes the software, the top three layers. The operating system is the middleman, so to speak, between the applications and the libraries and utilities upon which the applications depend, and the underlying hardware. Specifically, the core of the operating system, or the kernel, so named after, say, a kernel of corn, is the minimum piece of software that's needed to share the hardware between the different applications. Whatever lives outside the kernel that is software is said to be in user space. That means it's application code, or sometimes even parts of the operating system, that are not strictly necessary to share the hardware or abstract away its details. Now, operating systems implement a common mechanism for allowing applications to access the hardware, which is abstraction. And the applications make requests from the operating system to go and access the hardware or other features by making system calls down into the operating system. This is called entering the operating system, or entering the kernel from the top half. Operating systems are also able to alert applications that hardware has changed. Perhaps a network packet has come in. Perhaps the user has pressed a key on the keyboard. These alerts are delivered via a system called interrupts and refer to entering the kernel from the bottom half, from the hardware side of the operating system. We should also note that operating systems can manage and terminate applications by sending signals to those applications. Now, there are a wide variety of operating systems out there. They basically fall into two categories: Microsoft Windows, which is not Unix, and everything else, which is Unix. Microsoft Windows systems, non-Unix systems, are the most popular desktop operating systems at the moment. However, they're rapidly being eclipsed by tablet devices, most of which are running Unix-style systems. Windows is typically pre-installed by PC manufacturers, which accounts for a good portion of its present popularity. Unix systems, on the other hand, are installed by the end user, except for commercial Unix systems and Mac OS X. Mac OS X is probably the best-selling Unix system of date. And Linux, which includes the Android platform, is probably second. Now, there are some mainframe systems out there also, some of which are Unix-like. Some use custom operating systems. There are a variety of players in the embedded systems market. However, that's presently dominated by Android, with Apple's iOS, which is based on Mac OS X, in close second. Others, Symbian, BlackBerry OS, TinyOS, are confined to smaller markets. Now, the idea behind the Unix systems began with a time-sharing system started in 1964 called Multics. And the idea behind Multics was to make computing into a remote service that could be accessed by terminals using telephone lines. It wasn't terribly successful because dial-up connections of the time at about 9600 baud were rather slow. However, Canada actually did have a Multics system deployed and used it as part of their national defense network until the year 2000. Multics is remembered, however, primarily for its influence as a multi-user shared system. And today, with cloud computing, there's some significant parallels between some of the cloud computing models that we use and some of the ideas that were pioneered back in the Multics system. Now, Unix was actually a play on the term Multics. It was developed by Bell Labs in 1969. It's actually a trademark term, so some authors use Starnix to refer to the family of systems and use the word Unix only for the commercial distributions. The original Unix systems were commercial distributions, with free variants of BSD and Linux coming along late 80s and early 90s. Now, Unix systems are time-sharing systems in that they support multiple users at the same time, but they're designed to be run on local computer resources instead of remote resources. The Berkeley system distribution, which was based on AT&T's commercial distribution, was one of the first open source Unix systems to emerge. It was based on the commercial distribution, so AT&T sued UC Berkeley, but an eventual settlement allowed Berkeley to distribute BSD freely in both source and binary form. Today's descendants of BSD include FreeBSD, OpenBSD, and Mac OS X, which is based on the Unix BSD system. Linux, however, was an alternate approach to getting a Unix-like kernel running on a computer system. This was started by Linus Torvalds as an undergrad at the University of Helsinki, released in source code form in 1991, and often combined with a set of user space, utilities, and libraries created by the GNU project. Thus, the resulting combination is sometimes called GNU/Linux. It has been commercially successful for many device classes, including web servers, network and embedded devices, and mobile phones. Some people, including myself, use Linux as a desktop platform, and it does have the benefit of having one kernel that's scalable from embedded devices all the way up to supercomputers. Valuable tool for us in terms of learning about operating systems. Now, what is Linux? Well, generically, the term Linux refers to a class of operating systems that use a common kernel. Now, distributions of Linux, or operating environments as they're sometimes called, are cobbled together by taking the Linux kernel and adding various different user space tools to it. Many of these core tools originated in the GNU project, which originally started at MIT, and thus systems are sometimes called GNU/Linux instead of just Linux. I typically, however, say just Linux, referring to either the kernel itself or to the operating system distributions that are based upon that kernel. The Linux kernel was originally started as a hobby by an undergraduate at the University of Helsinki, a gentleman by the name of Linus Torvalds. He still heads the kernel development project. Now, Linux is what's called a monolithic kernel, and that means that the device drivers are built into the kernel. However, it's not a true monolithic kernel because the device drivers can be built as modules and loaded and unloaded from the kernel at runtime. The latest stable version was 2.6.37 on January 5th of 2011. That has since been updated to version 3.03, I believe, was the latest version that I've seen as of now, which is late August 2011. The latest version can also be checked by going to www.kernel.org. Here is an example of some of the main components of the Linux operating system. At the lowest layer, we have the computer hardware. And on top of that hardware, we have the Linux kernel. The Linux kernel contains a number of built-in subsystems that enable access to the computer hardware. These include drivers, memory management, process management, file systems, networking, including sockets and protocols, and other utilities that the kernel provides. On top of the kernel, we have the GNU C library, upon which most other libraries are based, since C is typically the lowest level system language to which all other software is eventually compiled. On top of that, we have our compiler, GCC, some important utilities called core utils, also part of the GNU project, and the born-again shell, or bash, which provides a command line interface into the system. All we need in order to run a Linux system and do useful things with it is everything below this line where I'm moving the mouse right here. All the software above this line is add-on software that's not strictly needed in order to run a Linux system, but makes Linux systems more convenient or do other things. So for example, we can add network tools such as Secure Shell Server and a generic services server called inetd that can launch all kinds of different services. We can also run a LAMP stack that stands for Linux, Apache, MySQL, PHP. If we're in a desktop scenario, we can also run a graphic user interface. This includes X11, specifically the X.org distribution, and one of a number of different environments that can be run inside X11. Popular ones include GNOME, KDE, and XFCE, which isn't on this particular graphic. Now, a large number of people have come up with different distributions of Linux. These distributions contain different sets of software, but they all share the Linux kernel in common. We typically classify distributions by which package manager they use. Unlike Linux and Mac system, Windows and Mac systems, where we install individual applications and then have to manually update each application by running separate installers, Linux distributions typically use package managers, which download and install extra software and update existing software with a single command. These package managers include the Red Hat Package Manager, or RPM, which is used in Red Hat Enterprise Linux, Fedora, Mandriva, OpenSUSE, and a number of other distributions. A competing package format is the Advanced Package Tool. This is used primarily by Debian and derivatives of Debian, such as Ubuntu. There are other binary formats, however, in use. Slackware uses a TGZ format with its own package management commands. Arch Linux has a custom-written package manager called Pacman, and there are some others out there. There are also source formats. Gentoo is able to build everything from source using ebuilds. Linux from scratch isn't so much a distribution as it is a book that tells you how to put together your own Linux system by compiling sources for each particular application. This is, of course, time-consuming. And there are other source formats out there as well. Now, in industry, Red Hat Enterprise Linux is quite popular. It's a Linux distribution from Red Hat Incorporated, which is based in Research Triangle Park, North Carolina. That's in the Durham area. It is an open source distribution, but the official product is sold with an update subscription accessed via per installation serial numbers. Therefore, in order to get the update subscription and the installation media, it's necessary to purchase the subscription from Red Hat. They do use the RPM package format. In fact, they invented it. RPM stands for Red Hat Package Format. CentOS is a free rebuild of Red Hat Enterprise Linux that's widely used in academia, industry, on many high-performance computing systems, and for many other applications. This, of course, uses the RPM package format and is available at zero cost. Fedora Core is a community distribution that's sponsored by Red Hat that grew out of an old product that Red Hat used to produce, which was called Red Hat Linux without the enterprise part. And Fedora is used to develop and test packages and infrastructure that are later incorporated into the enterprise Linux product. Debian is a fully open source distribution which avoids proprietary software and has an emphasis on security and stability. The stable version of Debian is extremely stable because the packages are extremely well tested. The flip side is that those packages tend to be rather dated, and thus an unstable version is available if more bleeding edge packages are needed. Debian uses something called the Advanced Package Tool, or apt, in order to manage its software. Ubuntu is actually based on Debian. It's sponsored by a company called Canonical Limited, which is based in South Africa. It's designed to be easy to use and friendly to new users switching from competing platforms. There's a new release every 6 months, and it's often necessary to completely reinstall the operating system at each new release. There is a functionality that's built into the Advanced Packaging Tool called Disk Upgrade, which seems like a great idea on paper, but in practice often doesn't work right and leaves the system unstable. Ubuntu also has a package pinning policy. Thus, once a package is released, it's only updated for security updates. If new features are added, one has to wait till the next version of Ubuntu comes out before getting the newly updated package. Now, Arch Linux, which is what I personally run, is a minimalist framework for creating a custom system. It's not so much as a distribution as it is a set of tools that enables each individual to create his or her own installation, customized to his or her own desires. It's a different philosophy from traditional distributions. It is a completely written from scratch distribution. It's not based on any other, and it is what's called a rolling distribution. There are not discrete versions of Arch Linux. Every time you run a system update on Arch Linux, you get the latest version of the operating system, along with the latest version of all application packages, and all the latest bugs. And the Pac-Man...
Okay. Okay, hindi ko siya natapos. Copy. Send ko na lang dito. Kung pwedeng panoorin nyo na lang on your time. On your extra time. No? Ayan. So, operating system. So, medyo marami siyang information na hindi kinover nung ating PowerPoint. Ayan. So, dito sa ating PowerPoint, it covers operating system services, no? Okay. So, papasadahan ko na lang ito next meeting. Isang pasada lang, tapos para tapos na natin. Operating system. Pero syempre sa Biyernes, ang ating ang ko-cover natin is yung ating assembly language. Ayan. So, since nabigyan ko na ng introduction to. Okay. So, oras na para matapos na tayo. Okay. Asan yung aking, ayan, dito. Stop ko na yung presenting ko. Ayan. Okay, class. Dami nating natapos na nasimulan tayo, no? Hindi pa rin natin na-rush. Anyway, at least nasimulan na natin yung OS. Gano'n tayong idea kung anong gagawin natin next Tuesday for OS. Tapos madadagdagan pa ng dalawa kasi dalawa per yan eh. Okay, so mag-ready na tayo next meeting for assembly language. Simulan natin uli sa simula at i-verify natin kung naka-install na kayo ng assembly language, and probably makapag-code tayo ng Hello World and a little bit of lesson, the following lesson after Hello World, no? So, yun yung ating objective next meeting. Ayan, na-cover na natin yung kaya nating tapusin ngayong araw na to. Okay. So, 4:30 na. Okay. Bago tayo maghiwa-hiwalay, kailangan kong kunin ang inyong mga lovely faces para sa ating attendance. Okay. Pahingi po ako ng mga lovely faces ninyo. Ayan. Juan Paulo. Okay. Ken Layug, Matt, Jericho, Wilbur, Oliver, Joseph, Eman, Lance, Rogelio, Josel, John Nicole, nagro-roll call na ako, Francis, Cherian, ayan, okay, baba ko to, ayan, dito ako pupwesto, okay, si Ken nasa baba, natatakluban, ayan, okay, kukunan ko na ng picture ha, ano ba, laging tumataas, ano ba ang gagawin ko para alam ko na, tatanggalin ko to, ayun, ganun pala dapat, ayan, right, okay, print screen, ngiting panalo dyan, okay, ngiting panalo, 1, 2, 3, smile, ayan, ito pa, 1, 2, 3, smile, okay, okay, salamat, ayan, nakuha ko na yung ating print screen, okay, so may question pa ba kayo dun sa ating diniscuss at saka yung ating gagawin next meeting? Okay, class, meron pa ba kayong gustong itanong at i-verify? Mali, hindi yan. Ayan. Okay, done.